How a machine weighing almost 400 tons made crossings of the ocean accessible to ordinary here and immediately on a grand scale. This is not just an airplane. It is a break in how we move around the planet. One airliner, which nearly bankrupted its maker, became the most recognizable airplane in history. It carried presidents, bore space shuttles on its back, flew with engines out over the ocean, and almost never came into being because experts called the project impossible. This is the Boeing 747, the queen of the sky. Today we will go through 20 facts that will show why this airplane did not just fly, it rewrote the rules of aviation. Fasten your seatbelts. The talk will be large in scale, the facts precise, and the consequences big. 1. The world's first wide-body passenger jet. Introduced into regular service in 1970 by the airline PNM, the 747 became the first commercial wide-body aircraft. Before it, passenger airliners were essentially narrow-body, one aisle, smaller cabin volume, limited range, and payload. The 747 changed that. 2 aisles, a huge cabin, enlarged cargo holds, intercontinental range, together a new architecture that set the format for long-haul aviation. And when it entered service, the world saw that more people and cargo could be moved between continents at once. It was not just a technological leap, it was a new logic of transport. 2. A development that could have buried the company. Creating the 747 cost roughly $1.3 to $1.5 billion in the late 1960s, an incredible sum then and equivalent to more than $9 to $10 billion today. Boeing assumed the risks, about $1. $2 billion was raised as loans, an amount exceeding the company's market capitalization at the time. A project on which the company's future depended, machine no one had seen before. If the project had failed, the debt load could have destroyed the company. The 747 was not just a new airplane, it was a bet on the future. 3. The Everett plant as a symbol of the task scale. To assemble this giant, Boeing built a plant in Everett, Washington. At its opening in 1967, it was the largest building in the world by interior volume, more than 13 million cubic meters. Building the infrastructure proceeded in parallel with design and assembly preparation. That is what it means to fit real life to the ambitions of engineering thought. Such scale required coordination of hundreds of teams, logistics for thousands of parts, and methods aviation had not known before. 4. The hump not for luxury but for function. The famous upper deck of the 747 appeared not as a design flourish but as an engineering necessity. The cockpit was raised to provide for cargo loading through a nose door that opens upward. Boeing calculated that cargo transport would be an important part of the business, and that hump was a direct response to a practical problem. Only later was the upper deck used for passengers, turning a functional solution into a symbol of status and comfort. 5. Wings as enormous fuel tanks. Fuel on the 747 is carried in the wings and central fuselage tanks. Volumes vary by version, roughly from 48,000 to more than 60,000. On the 747 to 400, the total volume reaches about 57,000. That is more than 210,000 liters. Such an amount of fuel is not just an energy reserve. It is part of the structure. Fuel distribution affects center of gravity and structural loads during flight. Can enter it through service hatches for inspections. Storage and technical zone. 6. It survived a complete engine shutdown. On the 24th of June, 1982, flight RWS-009 from Kuala Lumpur to Perth, at an altitude of about 37,000 feet, encountered a cloud of volcanic ash ejected by the Indonesian volcano Galunggung. The crew first noticed unusual glowing in the engines, then all 4 power plants sequentially stalled. The cause was volcanic ash. Microparticles melt in the hot parts of the engine and disrupt compressor and turbine operation. The airplane began a rapid descent and lost approximately 25,000 feet of altitude. But even in such a critical scenario, electrical power and main systems continued to operate from auxiliary sources, and after exiting the densish layer, the crew restarted the engines one by one, first one, then the others. The airliner landed safely in Jakarta. This episode became a turning point not only for airlines but also for global flight safety. Afterwards, International Volcanic Ash Monitoring Centers, VAAC, were created and procedures for flying near active volcanoes were revised. 7. Certification and behavior in an engine-out condition. The 747 was designed in an era when 4-engined aircraft were preferred for oceanic flights, and by certification rules it had to retain controllability and sufficient thrust with one engine out, both on takeoff and in cruise. When one engine fails, the crew compensates for thrust asymmetry with the rudder, and by adjusting the remaining engine settings, the airplane is capable of either continuing to climb or proceeding to a diversion airport. This redundancy made the 747 a preferred choice for remote routes. Practice confirmed the theory. In 1991, a China Airlines freighter Boeing 747 lost one engine after a pylon attachment failure but retained control and returned to the cases showed that the structure was engine. The presidential airplane based on the 747. On the 747 platform, the United States presidential airplane was created. The VC-25A, known as Air Force One, built on the Boeing 747-200B. This is not just a representative airliner, it is equipped with aerial refueling capability, which gives the theoretical ability to remain airborne practically indefinitely. Limitations are imposed only by technical regulations and human factors. On board are protected communications channels, command facilities, a medical suite, and systems protecting against an electromagnetic pulse. The structure is strengthened for autonomy and resilience to external threats. And with all that, its basic aerodynamic platform and flight characteristics remain based on the civil 747-200, an example of how a commercial development turns into a national instrument. 9. Transporting space shuttles. NASA used two modified Boeing 747-100s to transport the orbiters of the Space Shuttle program. Structural attach points were installed on the upper fuselage, and to compensate for the additional drag and mass the aircraft received reinforced structures and modified vertical tail elements. The compromise was obvious. Increased drag and mass reduced range and speed, but allowed safe ferrying of shuttles between landing sites and Kennedy Space Center. Operation of these modified 747s lasted from the late 1970s until the shuttle program ended in 2011. This is one of the most vivid examples of adapting a civil aviation platform for space program tasks. 10. An electrical network as long as a city. Inside the Boeing 747, approximately 170 miles of wiring are routed, about 270 kilometers. It controls avionics, the fuel system, hydraulics, air conditioning, and passenger entertainment systems. Installing such a network takes months and requires a dedicated team of specialists. For an aircraft of the late 1960s, this level of electrical complexity was a genuine revolution. Today, it seems self-evident, but then it was one of the key engineering achievements of the project. 11. 6 million parts and global cooperation. The Boeing 747 includes about 6 million individual elements. Each element had documentation and a quality control system. Manufacturing cooperation covered thousands of suppliers, and if a defect in a specific batch was found, it was possible to trace which aircraft that part had been installed on. Such traceability and control became an industry standard. The scale of the 747 project showed for the first time that creating a wide-body airliner is not the business of one factory or one country, but a global engineering cooperation. 12. Cargo versatility through the raised nose. The freighter version of the 747 is equipped with a nose that lifts. The flight deck is located above the main deck precisely so the forward section can open freely. The nose door lifts upward by hydraulic mechanisms, allowing loading of oversized cargo directly from the ramp level. Through it, they transported jet engines, industrial equipment, helicopters, aircraft sections, and non-standard containers. This scheme made the 747 one of the most versatile cargo aircraft in history. Even after the end of the mass passenger era, freighter versions continue to operate actively. 13. The economics of long-haul flights changed forever. Before the 747, intercontinental flights remained expensive and relative to 400 passengers in